everyone, myself Sai Prasad, a lecturer in AhleBait High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths A. We have started a discussion with the chapter Functions. What did we learn? We started with the basic theory, then the definitions, right? And we did few problems of functions, and then we started theorems. We did different theorems, that is G circle F whole inverse and so on and so, right? Let us do few more theorems and the problems of functions. Shall we start? See here. What is the function given? What is the theorem given here? Here he is telling that f maps A to B is a function, then f is a bijection if and only if there exists a function g maps B to A such that f circle G is equal to IB and g circle F is equal to IA, and in this case G is equal to F inverse. Right? Did you understand? Since it is too theoretical, you may not understand, but there are few things you have to learn, new things here. That is, if and only if. What do this means is, there are two kinds of statements in this theorem. From here to here it is one statement, and here to here it is one more statement. Okay? If and only if is a condition which is used in such a way that if there are two statements, statement A, statement B, let us assume. He tells that statement A is true if B is true, right, and vice versa. That is, if statement B is true, A is true. Okay, both are depending on each other. Okay, similarly, if F is a bijection, then it should be G is equal to F inverse. Okay, if G is equal to F inverse, F should be a bijection. This condition is the same for both the cases. Clear? Did you understand? Let us take in two different cases and solve it. Okay, that is, we'll assume this first, then we'll equate. We'll prove this. And in the second case, we'll prove this. We'll assume this and prove this. Clear? Shall we start? He gave that f of A to B is a function. Let us say it is a bijection, since here it is given. Therefore, f inverse B to A is also a bijection. Clear? Fine. Next, let us put G is equal to F inverse in their previous theorem, where we used to have that F circle F inverse equal to IB, G circle F inverse circle F is equal to IA, if you remember that theorem. From that theorem, if I substitute G instead of F inverse, then I will get F circle G equal to IB and G circle F equal to IA. Isn't it? Fine. And in that theorem, if you observe, F inverse, or else here it is G, F inverse itself is a bijection because it is a function, right? Because it is a function where its inverse is exists. So G is equal to F inverse. Since F inverse is a bijection, obviously F is also a bijection, right? That is, since G circle B to A exists such that G circle F is equal to IA is an injection. Okay, where we proved that G circle F is a bijection. From that, G circle F itself is an injection, therefore we can tell that F is a injection. Similarly, F circle G is a bijection, is a surjection. Obviously, F is an bijection from these 2 points, right? If you observe, what did we assume here? G equal to F inverse. Then we proved that F is a bijection. Clear? Fine. Similarly, let us take F as a bijection and let us prove G is equal to F inverse. Clear? Now see here. F maps A to B is a bijection, then obviously F inverse A to B, F inverse B to A is also a bijection, right? And he gave G maps B to A is also a function. If you observe here, G and F are on same domain. So let us assume two parameters where B belongs to B and A belongs to A. And since F maps A to B is a bijection, I can directly write it as F of A equal to B. From this, I can write F inverse B is equal to A, right? And I can tell that A as IA of A, isn't it? Yes or no? It is a identity function. What is IA given? G circle F. Let us write it here. Now let us separate it. G circle F of A can be written as G of F of A. What is F of A? That is nothing but B. Yes, right? What is G of B? That is nothing but F inverse of B. Since F inverse of B equal to G of B, then I can write it as F inverse is equal to G. Is it clear? Right? This is the only big theorem you have to remember. Remaining all other theorems are so simple and you can easily understand. Clear? You do understand? Fine. Shall we move to the next theorem? Let's do. Look at this question here. He is telling that there are three functions: f maps a to b, g maps b to c, and h maps c to d. Then he is asking us to show that h circle g circle f equal to h circle g circle f. Right? It is completely composite. So let us. This is a set A, B, C and D. Clear? He is telling that f is a function mapping from A to B. The next, g is a function mapping from B to C. H is a function mapping from C to D. Okay, then he is telling that H circle, G circle, F. From where does it map? Let us write. See here. That is f maps a to b is a function. The next, g maps b to c is a function. The next, h maps c to d is a function. Isn't it? So let us write this g circle f. That is g circle f. That is the root starts from f to g, that is a to b, b to c. Therefore a to c is a function. Is it clear? Now let us do from h circle, g circle, f. So the root starts from a to c, that is from g circle f, then it goes to h. Check whether c is common. So it maps from a to d is a function. Clear? Similarly, let us write this for second part, h circle g circle f. Let us write for h circle g. Okay, h circle g bole to it starts the root from g. Where is g? From g to h, b to c, c to d. Yes, it is happening. Therefore b to d is a function. The next is h circle g circle f. So the root starts from f. F is a to b, h circle g is b to d. Therefore it goes from a to d is a function. Is it clear? Now if you observe, h circle g circle f and h circle d circle f both are mapping in the same root, that is a to d and a to d. So they are on same domain. Therefore h circle g circle f and h circle g circle f are on same domain. Clear? Now let us take some such that a belongs to a is a number. Let us take it. That is h circle g circle f of a. Okay, let me take for the left ones and the right hand side ones. That is equal to h of g circle f of a. Right, that is equal to h of g of f of a. Clear? What is f of a? F of a is nothing but b. Clear? That is h circle g of b. Now what is b? Tell me. Here it is g of b is equal to c. Right? This is nothing but h of c. Now tell me what is h of c? H of c is nothing but d. Clear? Fine. This is nothing but d. Let us put it like that. Now let us write this part. H circle g circle f of a, that is equal to h of g of f of a. What is this f of a? B, right? That is h circle g of b. Clear? that is nothing but h of g of b. What is g of b now, tell me? C. Now what is h of c? D. Therefore if we observe from these both, I can directly tell that therefore h circle g circle f is equal to h circle g circle f. Clear? That is similar to your normal addition subtraction. A plus b plus c is equal to a plus b plus c. That is, they are commutative. Here also the composite function itself is a commutative function. Clear? Is it easy to solve? Now tell me, from where does this h circle g circle f goes? G circle f goes from A to C, right? G circle f moves from A to C. Then what about h circle g? H circle g moves from where to where? B to D. H circle G. Now tell me, from where to where h circle g circle f move? From A to D. Clear? Is it okay? Shall we do few problems based on these theorems? Look at these questions here. Here he is telling that f maps R to R and g maps R to R are two functions defined by f of x equal to 4x minus 1 and g of x equal to x square plus 2. Right? Then he is asking us to prove that g circle f of x. Okay? That is, what is this g circle f of x? G circle f of x is nothing but g of f of x. Isn't it? That is g of, what is this f of x? Tell me. 4x minus 1. So instead of x we are going to substitute 4x minus 1. That is 4x minus 1 whole square plus 2. Let us simplify it. Okay. This is, if you want to put as it is you can put, or else if you want to substitute you can. That is 4x minus 1 is 16x square plus 1 minus 4 to the 8x plus 2. That is nothing but 16x square minus 8x plus 3. This is g circle f of x. Clear? Similarly, he is asking us to find g circle f of a plus 1 by 4. Already I have g circle f of x, right? Instead of x, let me substitute this. That is g circle f of a plus 1 by 4 is equal to 16 a plus 1 by 4 whole square minus 8 into a plus 1 by 4 plus 3. If you wish to simplify, you can. 4 ones are 4 twos are, and here 4 square will get cancelled. Here it is a plus 1 whole square. A square plus 1 plus 2a minus 2a minus 2 plus 3. That is nothing but a square. 3 minus 2 is 1, 1 plus 1 is 2. This is the answer. Clear? Fine. Now look at this question. F of y equal to y by under root 1 minus y square, g of y equal to y by under root of 1 plus y square. He is asking us to prove f circle g of y is equal to y. Okay. Let us do it. F circle g of y is equal to f of g of y. Isn't it? That is f of, what is g of y? Y by under root 1 plus y square. Clear? Now let us substitute this in term of this y. Okay, that is y by under root 1 minus y square by under root 1 plus, what is y? This is 1 minus, right? What is y? Y square by 1 plus y square. Clear? Don't get confused here. Most of the questions which they give, they will be almost like this only. Mostly similar. Okay. Instead of this y, we are going to substitute this part. That is y by under root of 1 plus y square. 1 minus, instead of this y, we are going to write this. Square of this is y square, and the denominator, since it is under the square root, we remove the square root. Clear? Nice. See here. Is it right? Did we do any mistake? So it is 1 plus y square. Now y by under root 1 plus y square whole divided by under root LCM is 1 plus y square, right? Here y square will get cancelled. That is nothing but y by under root 1 plus y square divided by root 1 is 1 by under root 1 plus y square. These both will get cancelled. I will get the answer as y. Isn't it? Therefore, f circle g of y is equal to y. Is it easy to solve? Fine. Shall we move to the next problem? Let's do. Now see here. The next question he gave f of x is equal to 2. G of x is equal to x square. H of x is equal to 2x. So, f circle, g circle, h of x. F circle, g circle, h of x. That is nothing but f of g circle, h of x. That is nothing but again f of g of h of x. What is h of x? Tell me. Is 2x. Okay. Now let us substitute this 2x in this g, that is f of 2x whole square. Okay, that is f of 4x square. Clear? Now let us substitute this 4x square instead of this, that is nothing but 2. Right? Whatever you substitute, whatever it is there, f of something is always 2 because it is a constant function. Is it clear? Fine. What all we have learned today? We started with the two theorems. Okay. Then we discussed a few problems on those all composite functions, right? Fine. This is for today. Let us meet in the next session with the more problems of functions. Thank you.